Hello, my name is Funda Chiponda. I did a research with the Lumiere Research Program during the 2025 summer cohort. My research title was the environmental, economic, and social feasibility of producing bioplastics from sugarcane byproducts in Zambia. I conducted this research under the mentorship of Elizabeth Arenas, a PhD candidate in biological sciences. To begin, plastics are a widely used invention. This is due to their durability, low cost, and versatility. Global production of plastics has increased from 1.5 million metric tons in 1950 to over 267 million metric tons in 2020. The problem with plastics is that they are highly resistant to degradation, meaning they can persist in our environments for hundreds of years, causing major environmental challenges. Plastic pollution is a global issue. However, developing countries like Zambia face worse impacts due to poor waste management and lack of infrastructure. For instance, only 10% of Zambia's 80,000 tons of plastic waste is managed properly. The rest is either burnt or openly dumped in various places, causing severe pollution and health risks. Why is this research important? Zambia is currently facing a plastic pollution crisis due to insufficient waste collection and poor recycling infrastructure. This makes it crucial for eco-friendly alternatives to single-use plastics. One promising solution to this is bioplastics, plastics that are made from renewable resources like sugarcane bagasse, which offer a high biodegradability, reduced pollution, and support for circular economy. Zambia's sugar industry generates large amounts of sugarcane bagasse, currently used mainly for bioenergy and animal feed. However, its potential for high-value applications, such as bioplastic production, remains unexplored. When you look at countries like Brazil and India, they have successfully developed sugarcane-based bioplastics, yet there is little research on local feasibility in Zambia, even though it is one of the largest sugarcane producing countries in Africa, producing over 3 million tons of sugarcane annually. Therefore, this study evaluates the environmental sustainability, the social acceptance, and economic viability of producing bioplastics from sugarcane bagasse in Zambia. Moving on to my research question and hypothesis. My research question was, how economically, environmentally, and socially feasible is the production of bioplastics from sugarcane byproducts in Zambia? To that, my hypothesis was, if sugarcane bagasse is converted into bioplastics, it can serve as a sustainable substitute for conventional plastics, thereby reducing plastic pollution while adding economic value to agricultural waste. To test my hypothesis, I used both primary and secondary data. The primary data was collected through a structured survey, which was administered both online and in person to a total of 80 participants. The survey consisted of 16 questions, which were divided in 5 sections. The demographic information, which included age, sex, occupation, and the region of the participants. Social feasibility assessed awareness of bioplastics, severity of plastic pollution, willingness to adopt bioplastics. Economic feasibility explored opinions on job creation and preferred investors. Environmental feasibility probed deeper into views on using bagasse to reduce plastic pollution. And lastly, open-ended questions examine government and public roles in reducing plastic pollution and bioplastic production hindrances. The sample areas to this survey were the Copperbelt Province, Mflira and Chingula District, and Lusaka Province. The reasons for this selection was the high population density and high plastic usage in packaging and manufacturing in these two provinces. Secondary data was collected from reports from credible organizations such as FAO, UNEP, World Bank, and ZEMA. The data was used to contextualize and validate survey findings. It also helped assess national and global data on plastic production, waste management, and bioplastic potential. For my results, I found that socially, most participants recognize plastic pollution as a serious problem and strongly supported finding alternatives. However, awareness of bioplastics was low, as only 22% had heard of bioplastics before. Despite this, 89% believed eco-friendly alternatives are necessary. Top adoption factors of bioplastics included environmental friendliness, quality, and price. Overall, awareness is low, but willingness to adopt and support for alternatives are strong. Economically, 77% believe that bioplastic production would create new jobs, which is a major incentive given Zambia's youthful population. 71% preferred government-private investments to balance funding and innovation. Zambia is currently producing approximately 1 million tons of sugarcane bagasse annually, offering cheap local feedstock. Price sensitivity exists, but environmental concern outweighed cost for most of the participants. Ongoing circular economy policies and funding, for example, the Green Tech 4CE and the Zanaco Green Challenge, further supports feasibility. Environmentally, 91% supported the use of agricultural waste, sugarcane bagasse to be specific, for eco-products. 80% believed bioplastics can reduce plastic pollution to a great value. Bioplastic production aligns with Zambia's circular economy goals and reduces carbon footprint, which is a major positive factor. Environmental factors such as climate and land for sugarcane plantations are favorable, seeing that Zambia Sugar produces over 3 million tons of sugarcane each year. To wrap up my research, I concluded that bioplastics from sugarcane waste offer a sustainable solution to plastic pollution in Zambia, and bioplastic production in Zambia is socially acceptable and environmentally feasible, but its economic viability would depend on government support, public awareness, and private and government sectors' investments. For further directions, I would suggest exploring other agricultural byproducts, test small-scale bioplastic production from local sugarcane byproducts, and assess large-scale manufacturing and market adoption of bioplastics in Zambia. Thank you so much for listening to my presentation. Have a nice day.